Okay, ladies and gentlemen, this is Math Message 5-6, the main math lesson of the day. And in this lesson, we're going to solve multiplication problems using the doubling strategy. Now, we looked at the doubling strategy already yesterday, so you should be somewhat familiar with it. So we're just going to do a little bit more practice today. Now, today we're going to do something a little bit different. We're going to start out with our workbook, which we don't normally do that, but I want you to turn in your workbook to page 168. Needed to double check to make sure that was the right page. Page 168. Pause the video and get your workbook ready. All right, let's look at the math message at the top here. Number 1, it says blank is a double of 3 because half of blank is 3. So what is a double of 3? Well, 3 and 3 is 6, right? So 6 is a double of 3 because half of 6 is 3. Let's look at number 2. Blank is a double of 5 because half of blank is 5. So what's a double of 5? Well, 5 and 5 is 10, right? Because half of 10 is 5. Blank is a double of 9 because half of blank is 9. So what is a double of 9? 9 and 9 is 18 because half of 18 is 9. So boys and girls, look at all of these doubles. What do all of these doubles have in common? Hopefully you notice that all of them are even numbers. Okay, they're all even. Now, isn't that weird? Because these numbers aren't even, right? But our doubles are all even. Why does that happen? Even when the number we're doubling is odd, we get an even number. Well, let's think about that. If I have 3 people in line, that's an odd number, right? If I have 3 people in my class, I can't put them in partners because there's going to be an odd person out. I can group up these 2, but then there's one left out. But if I have another 3, well then, again, these 2 can get together, these 2 can get together, and then the odd guys out can now get together. Okay, so even when we are doubling odd numbers, we're going to have an even number because those odds can get together. Let's look at 5. Prove it again. So I've got 1, 2, 3, 4, 5 kids in class. Well, these 2 can get together. These 2 can get together. I have one that's left out. But if I double that and I have another 5, these 2 can get together. These 2 can get together. And the odd guys out can now get together. So now I have an even number. Okay, so anytime you're doubling any number, your answer is always going to be even. Even if I'm doubling a number that's already even. So I'm doubling 4. Well, when I double 4, what do I get? 8. If I double 6, what do I get? 12. Right, so even when I'm doubling even numbers, I'm always going to have even numbers. All right, so that's going to be important as we're looking into this doubling strategy. You've got to remember that when you're doing the doubling strategy, you're looking for even numbers. All right, keep that in mind. Let's look down below at number 4. It says your friend is planting a rectangular garden that is 6 feet wide by 7 feet long. Now, to buy the correct amount of fertilizer, she needs to find the area of the garden, but she doesn't know how to solve 6 times 7. Show how your friend could use the doubling to figure out the area. So boys and girls, there's a picture of her garden here. It is a 6 by 7. She's got to find the area to get that fertilizer to cover that area, right? So she's going to have to multiply 6 times 7, but she doesn't know the answer to that. I want you to go ahead and pause the video and see if you can figure out how to use doubling to figure out the answer. Go ahead and pause that video. All right, let's look at this. I said even numbers are going to be the ticket for this strategy. Which one of these numbers is even? The 6, right? So I'm going to take the 6, and what if I broke the 6 in half? and did 3 and 3. What if I found the area of this section first? Is 3 times 7 a little bit easier to do? Because then I could just kind of skip count by threes, or I could think, well, 7 plus 7 plus 7, right? So that might be pretty easy to do. So if I know that 3 times 7 equals 21, well, then another 3 times 7 equals 21. So what does 6 times 7 equal? Well, when I use that doubling strategy, now I'm going to double it back together, and 21 and 21 equals 42. All right, so the area of 6 times 7 is 42. The area of your friend's garden is 42 square feet. Boys and girls, that is using the doubling strategy. All right, let's look at another problem. Go to number 5. It says your friend changed her mind. Now she wants her garden to be 4 feet wide and 8 feet long. She needs to find the area of this garden, but again, she doesn't know how to solve 4 times 8. So here's a picture of her garden, her 4-foot by 8-foot garden. Use the doubling to help her solve 4 times 8 and show your work below. All right, go ahead and pause the video and see how you would solve this problem. All right, this one, again, think of that doubling strategy. I told you looking for that even number is going to help you with this doubling strategy. So when you're using this strategy, which of these factors is even? They both are, right? So actually, this strategy could be done 2 ways. So let me go through both ways you could have done this. All right, 4 is an even number, right? So could I break 4 in half? I sure can, right? Break 4 in half. I've got 2 and 2. So now the area of this garden, this is a 2 by 8. Oh, that's really easy to do, isn't it? Anybody can do 2 times 8. That's 16. Then down here, of course, it would be 2 times 8 again, because all we did was cut it in half. And now to find the area of the whole thing, I just need to double those numbers back together. 16 plus 16 equals 32. Now, I told you there were 2 ways I could do this problem. I'm going to draw this rectangle again over to the side. And again, I'm going to draw a 4 by 8. Now, the 8 is also even, so I could actually cut it this way and make it 4 and 4. So now the area of this side is a 4 by 4. That's easy, right? Floors, they need clean. 4 times 4 is 16. That's one of our square facts, isn't it? And then this side is also a 4 by 4 equals 16. When I double those back together, I'm still going to get 32. So the area of your friend's garden, a 4 by 8, is 32 square feet. All right. Whoops, I guess I didn't realize there was another part down here. It says find a different way to use doubling to help your friend find the answer to 4 times 8. So I kind of did both of them up there. I didn't realize I needed to scroll on down. So I could have broken the 4 and did 2 times 8 and 2 times 8, or I could have broken the 8 and done 4 times 4 and 4 times 4. All right, so there was actually a space for you guys to do both of those strategies. If you did not show both ways already, go ahead and pause the video and break the bottom rectangle differently than you broke the top rectangle. All right, let's look at these problems, boys and girls. It says, when would doubling be useful? So let's look at the problem 5 times 7. Would you use doubling to do 5 times 7? I wouldn't for 2 reasons. Number 1, it's times 5. Do we need to use the doubling strategy for times 5? Isn't times 5 one of our easy helper facts, right? We could just count by 5s. Another reason I know I can't use the doubling strategy is what did we keep saying about the doubling strategy? we have to have an even number in this problem. 5 and 7 are both odd numbers, so I cannot use a doubling strategy for this one. All right, what about 4 times 3? Could I use doubling to do 4 times 3? And I could, couldn't I? 4 times 3, which one of these numbers is even? The 4. I'm going to come over here and draw a rectangle, and I'm going to make this a 4 by 3. Actually, I'm going to do it that way since I made that side longer. And now, if that's a 4 by 3, I can break that 4 into 2 and 2. Over here, I can do 3 times 2, which equals 6. And over here, I can do 3 times 2, which equals 6. And when you put those two together, 6 and 6 equals 12. Okay, would you use doubling for 9 times 9? And I would say no again for 2 reasons. 1, 9 times 9 is one of my squared facts. It's really a fact I should be working to memorize. 9 nines, having fun. 9 times 9 is 81. So hopefully you're committing those square facts to memory. So I wouldn't use it for that reason, but also neither one of the factors are even. So am I able to cut one of these factors in half so that I can do that doubling strategy? Nope, so that would not work. All right, and then I have my 6 times 8. Would the doubling strategy be useful for this problem? And absolutely yes, it would, okay? Because again, both of my factors are even. I have 6 by 8. I could either break the 6 into 3 and 3 and do 3 times 8 up here and 3 times 8 down here. 3 times 8 is 24, and if I know that, of course, it's down here again. Double that up, 24 and 24 is 48. Or I could have broken the 8. Break the 8 into 4 and 4. So I would have 6 times 4 over here and 6 times 4 over here. 6 times 4 is 24. 6 times 4 is 24. So 24 and 24 again is 48. So boys and girls, anytime you have a factor that is an even number, you could take that factor, break it in half to make it easier, and then just double those numbers back together. Now, to do this strategy, boys and girls, in the beginning, to keep practicing this doubling strategy, I'm going to really require you in the beginning to show me that in an area model. And by what I mean by that is drawing that rectangle out. Now, you're going to get tired of doing it. You're going to say, I can do it without the rectangle. And I know you can, and eventually I'll say, okay, you don't have to draw the rectangle anymore. But for now, we're going to be using the rectangle. So let me give you another problem. Have whiteboard or pencil and paper out and ready to go. I'm going to give you a couple more problems. All right, let's do 4 times 9. I know I can use a doubling strategy because I have an even factor. 4 is an even factor. Now, again, I'm going to require you to draw the area model. So you have to draw a rectangle, and you have to go ahead and label your sides. So this is a 4 by 9. Now remember, you take the side with the even factor, and what are you going to do to it? Go ahead and pause the video and see if you can work out this doubling strategy using this area model. All right, I'm going to take the 4 and I'm going to break it in half. I like to just draw my line clear out there because it reminds me I'm cutting that 4 into 2 and 2. Now this is easy math. I've got a 2 by 9 up here. And 2 times 9 should be easy. It's a doubles fact, so I've got 18. And then I've got 2 times 9 down here, and again, 18. And then this doubling strategy says, now I just put those two halves together, add them up. 18 and 18 is 36. So 4 times 9 is 36. Let's try another one. All right, what if I gave you this time 4 times 7? I know the doubling strategy will work because one of my factors is even, and I'm going to let you in on a secret. Anytime I do times 4, I use the doubling strategy. Anytime. Okay, so draw out your rectangle, label your sides. That's a 4 by 7. All right, which side are you going to cut in half? I'm going to cut through the 4, make that a 2 and a 2, right? That's why anytime I do times 4, I do the doubling strategy because now I can do 2. I can just do times 2 and then double it. So 2 times 7 is what? 14. 2 times 7 is 14. 14 and 14, put it together. You've got 28. All right, so boys and girls, I encourage you to, if you kind of are questioning this strategy a little bit, why don't you go through and do several problems? Maybe do a 4 times 8, maybe do a 3 times 6, maybe do a 6 times, let's see, have we done a 6 times 7? Yes, we did a 6 times 7. How about a 6 times 8? Do any problems, anything times 4 or times 6, and use that doubling strategy on it. So try several problems with something times 4 and something times 6, and use that doubling strategy. Take that even number, break it in half, and then double it back together again. All right, we have a little bit more practice to do with this particular lesson. So go ahead and turn in your workbook to page 171. And you are going to be working on a picture graph. So go ahead and pause the video, work on this page, and then you can restart the video and check your work. Okay, so looking at this again, it was creating a bar graph from a picture graph. So I really didn't read those directions very clearly at the beginning, but you're going to use the information shown in the picture graph to then create a bar graph with the same data. Okay, remember to add labels and title your graph. So boys and girls, the title of this picture graph is Visitors to Big Bend National Park. So you're going to do the same thing for your bar graph. You're going to call it Visitors to Big Bend National Park. Now, you're creating a bar graph out of this information. So boys and girls, with a bar graph, typically our picture graphs typically run horizontally like this. Now, we learned in class that typically when we do our bar graphs, that same information would be running like this, right? So now, for our day 1, day 2, day 3, day 4, day 5, day 6, day 7, where's that information going to go? In a bar graph, that's going to go at the bottom. So you should have had day 1, and I'm going to kind of go a little quicker, 2, 3, 4, 5, 6, and 7. But you could have written out day 1, day 2, day 3, and etc. Okay? Now, when I label that, these are my days, right? These numbers are my days. Now I have to create my scale over here. And this is going to be my number of visitors. So that's what you should have had labeled here. Number of visitors. And I have to decide on my scale. Now with a picture graph, they use a key. So every smile face is worth 50 people. So probably my scale needs to also count by 50s. So I'm going to start always with 0, and then I would have 50, 100, 150, 200, 250, 300, 350, 400, and so on, all the way up to the top of my bar. Hopefully I did that right. Talking and writing at the same time is not my specialty. All right, and now I'm going to fill in my bar. So day 1, I'm looking for 50 people. So 1, 2, 3, 4, 5, 6, 7, 8. I've got 100, 200, 300, 400, right? So I need to make my bar go clear up to 400. And then I can get that all shaded in. Okay? And then day 2, I would have had 100, 200, 350. So again, I'm going to make my bar go up to 350 and all the way down, and I can shade in. Now, I'm not going to do all of these for you, boys and girls, but I am going to go to day 3 at least, because what happens when I have half of a smile face? I have half of 50, right? So I have 100, 200, 300, 400, 500, 525. So when I'm doing that on a bar, I'm going to go to 525, which is going to be between 500 and 550. I always like to make the tops of my bars nice and crisp so I can really read them, because that's the important part, and then you can kind of chicken scratch shade in the rest of there. All right, boys and girls, that is it for converting your picture graph into your bar graph. And that's going to be it for lesson 5-6.